Every year, more than 1,000 police helicopters are manufactured around the world. They are some of the most advanced aircraft ever designed for law enforcement. Machines built to chase, track, observe, and operate where ordinary police vehicles simply cannot go. From hundreds of meters above the ground, a police helicopter can follow a speeding vehicle through a city, search enormous areas in minutes, illuminate dark streets, and track suspects trying to disappear into the night. But have you ever wondered how one of these machines is actually built? How do you transform hundreds of tons of raw materials, thousands of components, powerful turbines, and sophisticated surveillance systems into an aircraft capable of operating above an entire city? The answer takes us inside some of the most advanced aerospace factories in the world. Here, enormous metal structures are assembled with extreme precision. Turbines capable of producing enormous amounts of power are installed piece by piece. Advanced cameras, thermal sensors, and communication systems turn an ordinary aircraft into a flying command center. And before a single police officer ever climbs inside, the finished helicopter must survive a brutal series of tests designed to expose even the smallest failure. Today, we are going inside the factory to discover how a police helicopter is made, from an empty metal frame to a fully operational machine ready for the sky. Let us begin. Everything starts with the structure. Before the helicopter has cameras, engines, seats, or even a cockpit, workers must create the enormous metallic framework that will eventually become the body of the aircraft. This is the skeleton of the helicopter. And although it may look like little more than a collection of metal panels and structural components, this stage is one of the most critical parts of the entire manufacturing process. A police helicopter has to satisfy two requirements that seem almost contradictory. It has to be light enough to maneuver quickly, but strong enough to survive intense vibration, demanding landings, and the enormous forces generated during flight. That is why aerospace manufacturers use advanced materials such as reinforced aluminum, titanium, and carbon fiber composites. Each material has a specific purpose. Some components need to be incredibly strong, others need to remain lightweight, and some must survive constant vibration for thousands of hours. Inside enormous industrial facilities, automated cutting systems begin shaping the raw materials. Robotic arms move components into position, while precision machines drill and mill them to exact dimensions. Hydraulic presses shape larger structural elements, while specialized tools create the mounting points that will eventually connect the different sections of the aircraft. There is almost no room for error. A small structural imperfection can create unwanted vibration. A poorly aligned component can affect stability, and a problem that seems insignificant inside the factory could become extremely serious once the helicopter is flying. Piece by piece, the empty structure begins to transform. Panels are attached, structural members are connected, mounting points are reinforced, and slowly the silhouette of a helicopter begins to emerge. At this point, however, it is still nothing more than a giant metallic skeleton. It has no power, no surveillance equipment, no cockpit, and most importantly, it cannot fly. That is about to change. Once the main structure is complete, engineers can begin installing the component that will eventually bring the machine to life: the engine. Police helicopters require powerful aviation turbines capable of producing enormous amounts of energy while remaining compact and relatively lightweight. These engines are manufactured and transported under extremely controlled conditions before arriving at the final assembly facility. Some can weigh hundreds of kilograms, and every component inside them has been engineered to operate under extreme temperatures and enormous mechanical forces. Inside the factory, specialized cranes carefully lift the turbine and position it inside the helicopter's engine compartment. It has to be aligned precisely. Technicians then begin connecting fuel systems, electrical connections, cooling systems, and the transmission components that will transfer the engine's power toward the rotor. And then comes one of the most recognizable parts of the entire aircraft, the main rotor. Those enormous blades may look simple from the ground, but they are highly engineered aerodynamic structures. They must remain extremely strong while also being light enough to rotate efficiently. Each blade is carefully positioned and connected to the rotor assembly. Hydraulic lifting platforms help workers raise the components into position. Specialists then secure the connections and inspect them repeatedly. Because once these blades begin rotating, they are carrying enormous amounts of energy. The transmission system is then connected to the rotor. This is the mechanical link between the engine and the blades. The turbine produces the power, the transmission distributes it, and the rotor transforms that power into the force required to lift the helicopter. When the final connections are complete, something important has changed. For the first time, this machine has the potential to leave the ground, but it still needs a brain. Now the helicopter begins to look like the aircraft people recognize flying above cities. The cockpit is installed, but this is far more than simply a place for pilots to sit. Inside a modern police helicopter, the cockpit is essentially a flying command center. Control panels, navigation systems, communication equipment, tactical displays, and thousands of electrical connections are installed throughout the cabin. Technicians carefully route kilometers of wiring through the aircraft. Every cable has a specific destination. Every connector must be secured, and every electronic system must communicate correctly with the others. The helicopter may eventually carry information from cameras, navigation systems, radios, and tracking equipment simultaneously. All of that information has to reach the crew in a form they can understand instantly. The cockpit therefore becomes one of the most technologically complex areas of the aircraft, and depending on the aircraft and its mission, additional protection may also be incorporated into the cabin. Specialized windows and structural components can provide additional resistance against impacts and harsh operating conditions. The result is a cockpit designed not simply to fly, but to operate as a tactical platform. The pilots need to know where they are. They need to communicate with officers on the ground. They need to coordinate with other aircraft, and they need to maintain control of the helicopter while processing enormous amounts of information. But there is still something missing. The helicopter can fly. It can communicate, but it still cannot properly see. That is where the next system comes in. This is the moment when the helicopter transforms from an aircraft into a surveillance platform. Mounted beneath the fuselage is one of the most recognizable pieces of equipment on many police helicopters, the sensor turret. Inside this compact housing can be a combination of high-resolution cameras, infrared sensors, and thermal imaging systems. And unlike an ordinary camera, this system is designed to remain stabilized while the helicopter is moving. The turret can rotate, it can follow moving targets, and it can provide the crew with a detailed view of the ground below. But one of its most important capabilities is thermal imaging. A thermal camera does not need visible light in order to detect heat. That means that during nighttime operations, the system can help crews identify heat signatures that would be extremely difficult to see with the naked eye: a person, a vehicle, an engine, or another heat-producing object. All of these can potentially appear differently against a colder background. Inside the cockpit, dedicated displays allow the crew to monitor the information being generated by these sensors. Suddenly, the helicopter is not simply flying above the city, it is watching it. The system can track vehicles from the air, it can help search large areas, and it can give officers on the ground a perspective that would be impossible to obtain from street level. But the cameras are only part of the equation. The aircraft still needs a way to illuminate what is happening below. Now technicians begin installing the equipment that turns the helicopter into a fully operational police aircraft. One of the most visible systems is the powerful searchlight. Mounted underneath the helicopter, this high-intensity light can illuminate roads, vehicles, and large areas of terrain from the air. During nighttime operations, it can become an essential tool. A helicopter can illuminate a moving vehicle while officers on the ground coordinate the operation. And because the helicopter has an aerial perspective, the crew can continue tracking the target even when the vehicle changes direction. But the searchlight is only one component. Depending on the aircraft's configuration, additional communication and tracking equipment can also be installed. Long-range radios allow the crew to communicate with police units on the ground. Loudspeakers can transmit messages toward people or vehicles below. Tracking and navigation systems help the crew maintain awareness of the aircraft's position and surroundings. Antennas are mounted across the airframe, cables are routed through the interior, and every electronic component must be connected to the aircraft's central systems. At this stage, the inside of the helicopter begins to look less like an aircraft and more like a technological control room. But the helicopter still does not look like a police helicopter. The final transformation is about to begin. With the major systems installed, the aircraft finally moves toward the finishing stage. The exterior is prepared for painting. Surfaces are cleaned and inspected before the final coatings are applied. Then the aircraft receives the colors, markings, and identification associated with the police organization that will operate it. Slowly, the anonymous metallic structure becomes recognizable. The machine finally looks like the helicopters we see above cities, but appearances do not matter yet. The helicopter still has to prove that everything works. And this is where the manufacturing process becomes a test of survival. The engines are started for the first time. The rotors begin turning, slowly at first, then faster and faster. At the same time, computers and technicians monitor hundreds of parameters. Engine performance, temperature, vibration, pressure, electrical systems, rotor behavior, everything is watched. If something does not behave as expected, the helicopter does not fly. The problem has to be identified and corrected. Then the aircraft enters another series of ground tests. Controls are checked. Communication systems are tested. Navigation equipment is verified. The cameras are activated. The thermal sensors are checked. The searchlight is tested. And every system must work together, because a police helicopter is not just a collection of independent components. It is one enormous integrated machine. And then comes the moment everyone has been waiting for, the first flight. The helicopter leaves the hangar. The rotors accelerate. The aircraft becomes lighter against the ground. And then it rises. For the first time, the machine that began as pieces of metal and composite material is flying. But this is not a normal flight. Test pilots deliberately push the aircraft through a demanding series of maneuvers. They test acceleration, turns, climbs, descents, hovering, control response, and the behavior of the aircraft under different conditions. The objective is not to make the flight look impressive. The objective is to find something that should not be there, any vibration, any unusual response, any abnormal temperature, any system failure. Because if something is going to go wrong, the factory wants to discover it here. Not during a real police operation. Only after the aircraft has successfully passed its testing program can it be approved for operational service. The helicopter is finally finished, but manufacturing is not completely over yet. Now comes the final journey. Depending on its destination, the aircraft may fly directly to its new base. Others may be partially disassembled and transported using specialized heavy-haul vehicles. The helicopter leaves the factory and begins its journey toward a police aviation unit somewhere in the world. And this is where its real purpose begins. The aircraft that started as raw materials is now a flying surveillance platform. It can remain above an area for extended periods. It can coordinate with officers on the ground. It can search enormous areas. And during the night, when most people are asleep, It can continue operating above highways, neighborhoods, and city streets. From the ground, it may look like a simple helicopter passing overhead, but inside that aircraft are thousands of components working together. A turbine generating power, a transmission transferring that power, rotors producing lift, computers processing information, cameras scanning the ground, thermal sensors detecting heat, radios connecting the crew with officers below, and pilots controlling the entire machine while making decisions in real time. All of it began inside a factory. So the next time you hear a police helicopter flying over your city, remember what you are actually looking at. You are not simply seeing a helicopter. You are seeing the result of thousands of engineering decisions, hundreds of precision components, and countless hours of assembly and testing. From the first piece of metal to the moment it finally leaves the ground, every detail has one purpose: to create a machine capable of performing when it matters most. And perhaps that is what makes these helicopters so fascinating. Most of the technology that makes them extraordinary is completely invisible from the ground. The cameras, the thermal sensors, the computers, the communication systems, the turbine. All of it is working together, hundreds of meters above you. Now tell us in the comments, what part of the manufacturing process surprised you the most? And what incredible machine should we take inside the factory next? If you enjoyed this journey behind the scenes, leave a like, share the video, and subscribe to Source Code so you do not miss our next episode. See you in the next one.